Okay, folks, it's time to do binomial distributions, example 1, part D. So here we go with that. So let's be very careful when we read the question again. So we have Mario shooting 5 shots, that's n. Now, let's read the definition here. It says, what's the probability he will hit a certain number of shots? So we're back to the definition of success being hitting shots. In part C, we were talking about missing shots. We need to change that definition now. So again, I would always caution you to not necessarily put good or bad when it comes to what the stats nerds call success and failure. All right, the outcome the question mentions is called, quote, success, and the other one is failure. All right, but that's just terminology. Again, don't think good, bad. In part D here, all right, now we got to be careful here. This one says the probability that the number of shots he hits, which again is called X, all right, and this time it says at least one. He hits at least one. That doesn't mean just one shot. That means one or more. So if we think about this, let's see, what symbol would you put for that variable to be at least one or more? How about greater than or equal to, Mr. South America? Yes. Who said that? You. Yes. Yes, I agree with you. Greater than or equal to. Is that what you said? I don't remember now. I hope that's what you said. Greater than or equal to. Anyway, that's how you would say at least one. Now, I'll take you back to part B. When we filled in the entire probability distribution for hits, I want to remind you this was part B. And again, go back and watch it if you haven't already. It's awesome. But if you say at least one, that means you would need to calculate all the probabilities from 1 all the way up to 5. And that's the original question as it was described to us. Now, you got to pretend this hasn't been done yet. All right? So keep in mind, if you were going to do it what I would call the direct approach, you would need to set up the probability for 1, the probability of 2, 3, 4, and 5, and add them up. Well, that works. That's fine. But again, I would suggest to you, what if he shot 30 shots and we said at least one? That would be all the numbers from 1 to 30. And that would be a lot of work there. So let's be smart about this. Let's say smart and lazy, because that's what mathematicians are. We look for shorter ways to do things. If we remember that all the probabilities have to add up to 1, 100%, wouldn't it make sense to determine the probability that he does not hit any shots? And wouldn't that be the complement of what the problem wanted? So how about, wouldn't it make sense to figure out that probability, subtract it from 1, and that would give us all these that the question actually wanted. So the smarter way to do this question, and I know we talked about before break, at least one! That's a lot of different possibilities, at least one. Let's do the complement here. So I'm going to set up the probability that he hits 0 shots. And since that's the opposite, the complement of the original question, wouldn't that need to be subtracted from 1? I hope that made sense to everyone. I see that you're all nodding in agreement, so I will assume that that indeed made sense. So, here we go. 1 minus, that will set up 0. I'll give you 5 shots, choose 0 to hit. I don't care what order. You're going to succeed, 80% to the 0 power, which means you're going to fail on 5. You're going to hit 0 shots and miss 5. This, I'll remind you, is the opposite of the original question, and that's why we're going to take it away from 1. I hope this is not a coin flip for you. If you would look at that and say, okay, yeah, I know when to do the 1 minus, because the original question involved a wide range of numbers, and the opposite is only one number. That's smart. So anyway, and then you'd put this in a calculator. If you didn't have this in front of you, I admit I'm saving time and cheating, but just like earlier when we did part B, if you crunch that out, you will see that that's 0.00032, and then that, taken away from 1, would be 0.99968, and that's our answer. That should be what you would get if you calculate all the probabilities from 1 to 5 and add them up, but that would have been a lot more work. But I'll tell you this much, as a total nerd, if I had the time, and who doesn't have time nowadays, right? If you wanted to, you could go back and set up these probabilities from 1 to 5 and add them up just to be sure, and you would hopefully get that same number. So there's really two ways to do the question. If you want to do it both ways, hey, it's your life. Do what you want with it. But anyway, we'll be back in a minute to look at example number 2. Thanks.